Okay, let's try this more complicated circuit. So as you can see there, we have a battery, two batteries actually, 5 volts each, so that's a total of 10 volts. And we have a resistor. So 2 batteries here, total of 10 volts. And we have a resistor here with a value and a switch. There's a switch here and a resistor of 10 ohms. There is another switch here and a resistor, 10 ohm resistor. And we have this is an ammeter to measure the current here. The ammeter in this circuit, in these FET animations, the ammeter and the voltmeter are ideal. There was no way to change that. You couldn't change the resistance, which is assumed to be 0 for the ammeter, and the resistance of the voltmeter is supposed to be infinite. Okay, that's what the voltmeter, ideal voltmeter and ammeter have. So in this circuit, we have that ammeter measuring the current here. Then that I'm going to set to 0 for an ideal ammeter, and I'm going to change it to make it not ideal. Okay? And here is a resistor again of 10 ohms and a switch. So the main resistors here are 10 ohms here, 10 ohms here, and 10 ohms here. Then I have an ammeter here and a voltmeter measuring the voltage here. All right? So we're going to again open some switches and see how the voltages in the circuit should change, depending on which switch I open. So the first one that I'm going to start opening is S1. So I want you to think about what should be the voltage of the voltmeter. Well, let's figure out first why do we have those values there, or how would you calculate those values. So when all the switches are closed, you would have a voltage of 10 ohms, right? The resistances here are 10 and 10, so that is, and they're in parallel. So that makes 5, right? And that 5 is in series with 10, so that's 15. 15 ohms is the net current of net resistance of the circuit. So the current that should be flowing through this resistor should be 10 divided by 15 ohms, right? The current flowing out of the battery, none of it goes this way. Ignore this for a minute. This is going to be at the end when I talk about non-ideal voltmeter. So ignore that branch. The current is going this way, goes through here, then it splits in two. Part of it goes this way, part of it goes this way. We know how much is going here. That's already showing us. So the current that is going here should be equal to what? Should be the voltage, 10, divided by the net resistance, which is 15. 10 plus 5 for these two guys. Okay, so that would be 10 divided by 15, and that is the current. Now, how do I relate that to the difference in voltage across that resistor? Let me write that, what I just said. Let me write it down. So when they're all closed, the equivalent resistance of the circuit is 10 plus 5 ohms. So that means that the current flowing out of the battery is going to be 10 volts divided by 15. Right? So that's 2/3. That is the current that is flowing through that resistor. How much is the difference in voltage across that resistor? If I know the current, I multiply it by, if I know the current, I multiply by the ohms, and that should be the difference in voltage. So the current, I know that there's a small difference there. So the current should be, the voltage, difference in voltage across that resistor would be the current multiplied by the resistance, which is 10. So this should be 0.66 multiplied by 10. That should be 6.67. So what I have here is one of these things is not ideal. I'm going to have to get out of here. So this guy, that should be 0. Okay, so we're back to the ideal case. And the voltage, as you can see, is 6.66 as we just calculated, right? So back to that. The current we said was 2/3, which is 0.67 amps. And the voltage across that resistor should be the current multiplied by R, which is 0.67 times 10, 6.67. All right? So that's the measurement of that voltmeter there. All right. Why is 0.33 amps going on that branch of the circuit? Why 0.33 here? How much is going here? We just calculated that. It's 0.67. And this branch of the circuit has 10 ohm resistance, and this branch has 10 ohm resistance. So how much of that 0.67 amps is going to go on this branch? Exactly half of it, right? So 0.33 is half of 0.67. Right? We only have two significant digits here. So that's why that is measuring that. What would be the difference in potential, let's say, across this resistor? If I were to put the voltmeter measuring here and here, what would be that voltage? Should be the current flowing through it multiplied by its resistance. So 0.33 multiplied by 10. So that is 3.3. Yeah? So on this part of the circuit you have 3.3 volts, and on this part of the circuit here you have 6.6. Okay? The sum of them is 10, approximately 10. Right? So that's what you would expect. You go 10 up 10 this way, then you drop 6.7 here, and then you drop 3.3 here, and you're back to 0 over here. All right? So measuring the voltage here will give you 6.67. Measuring the voltage here will give you 3.33 will be here. All right? Again, the question now is, what about opening one of the switches? What would happen to those voltages if I open, for example, S1, which is the top one? So I'm going to open this switch, this one right here. What will be the voltage measured by the voltmeter if I do that? These are all good exam questions. If you're sleeping, you might want to wake up. So what should that voltage be if I open, let me show you again, if I open this switch? What is the reading of this voltmeter? Remember that you need to ignore this path because it's already open. This is, I'm going to use it at the end. So ignore that path. Your circuit is simply this, switch here, resistor, switch, resistor, switch, resistor. Okay? If I open this resistor, can somebody tell me what's the current in the circuit? 0. That's right. If the current in the circuit is 0, what can I say about the difference in potential across this resistor over here? And across this resistor? That's right. So if I move from here, I walk all the way along this line, and I walk through this resistor, have I changed my potential yet? Nope. This is all equal potential because there's no current flowing through these guys. They're acting as an ideal conductor. And when I go through this one, did I change the potential? Not yet. No current flowing through this. So this whole thing has the same potential. And that potential is the potential of the negative side of the battery. Yeah? And that's going to be the potential measured by this, voltmeter needle. Okay? Now this thing is open. If this is open, can I say that the potential here is the same as the potential here? If this switch is open, I cannot say that. Right? So when I open this switch, now this potential here is going to be the positive terminal of the battery potential. So look, I'm going to draw the points that have the same potential with one color. So all of the blue points have the same potential. This and that. And that's it. What about the other points? The points with the potential of the negative side of the battery. I move here. All of this in red has the same potential because there are no currents flowing through those resistors. So this whole thing has the same potential everywhere. Now if I measure the potential difference between this point and that point, what should it be? Which is 10 volts. 10 volts is the answer. That voltmeter's measurement is going to jump up to 10 volts when you open that switch. Okay? You're measuring that voltmeter connected between any blue point with a red point is going to show you 10 volts. Okay? Let me do that. So when I open this switch, that's what we said, it jumped to 10, right? We're measuring the potential. This side is blue, in my drawing was blue, and everything else was red, so watch. If I measure here, that's still 10. If I measure here, that's still 10. 10, 10, 10, 10, 10, 10, everywhere 10, right? All right. Let's close that one. So the potential, 10, and on the other side will be 0. If I were to measure the potential between these 2 points, will be 0, of course. We said that this is equal potential to this. Okay, so let's close that one. Let me see what's the next one that I chose to open. Let's open S2, which is this one right here. What would happen to the difference in potential measured by the voltmeter if I open that switch? If I open this switch, what's going to happen to the voltmeter reading? So the current no longer is going to go through this path. All right. So the circuit now looks like it's 2 resistors in series. All right. Those 2 resistors are identical. So what's the difference in potential across one resistor? If the total is 10 and you have 2 resistors in series, the difference in potential in each one is going to be 5 volts. That's right. If I open switch number 2, that voltmeter is going to show me 5 volts difference across that resistor. And there you have it. All right. See you next time.